Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Seva Gurukulam online classes in mathematics. We will see some interesting properties of a circle. And before we come to the topic, let us just revise what we have seen in the previous class. We have seen the definition of a circle. What is a circle? Circle is the path traced by a moving point which moves at fixed distance from a fixed point. Is it not? And what is the fixed point called? The fixed point is called center O, and fixed distance is called radius, and this path is called circumference. And diameter, what is diameter? It is the line joining any 2 points of the circumference passing through the center. That is diameter. And each diameter is equal to 2 times the radius, or radius is equal to half of the diameter. How many radius you can draw? Any number of radius you can draw. Any number of diameters you can draw. Is it not? And what about chord? Chord is a line segment joining any 2 points of the circumference of a circle. That is called chord. And what does the chord do? It divides the circle into 2 parts, and each part is called segment. The part of a circle formed by the chord is called segment. There are 2 segments. One is called major segment, another is called minor segment. Is it not? And when the chord becomes diameter, it becomes a semicircle. Is it not? Also, you have studied what is called as angles in a circle. Angle formed at the center of a circle. And also you have studied what is called the length of an arc. So when you say a chord AB, the angle formed by the chord at the center. Is it not? And this is called length of the arc. How do you find the length of the arc? 2 pi r into the angle here, say 30 degrees or 40 degrees, whatever it is, by 360. That is the formula you have studied. So this is the length of the arc. Total is called circumference and total length is 2 pi r. This is part of it. And this arc is called minor arc. And this part is called major arc. Is it not? And this is called center, this is called radius, and this is called angle at the center. Is it not? And if this becomes a semicircle, this will be angle will be 90 degrees. And at the center it will be 180 degrees. And at the circumference it will be 90 degrees. That also you have studied in the previous class. And also one important point also we studied that angle in the same segment. I am drawing a rough figure here. Suppose you have a arc called AMB. It forms angle at the circumference, namely APQ and AQB. See, here is a center and this is called angle formed at the center. Is it not? This angle formed at the center will be double the angle formed at the circumference. Suppose this is x. These two angles will be equal. That is what he said. Angle in the same segment of a circle are equal. How do you get segment? That is just by joining the chord. So these two angles will be equal and angle at the center will be double the angle at the circumference. That means suppose the angle is 30 degrees here, it becomes 60 here. That is the meaning. And this also will be 30 degrees. And these are things you already studied in the previous class. Now coming to the home assignments. First question. In the adjacent figure, PQR is the arc of a circle. So PQR is the arc of a circle with center O. If PTR is 35, what is PSR? So solution is by theorem. So PQR is the arc. PQR is an arc of a circle of center O, and also you are given PTR is equal to 35 degrees given. Now they are asking what is PSR. So we know that. Of course, some of you may say we don't know that. Means you have forgotten. Now you just remind, okay? What do you know? These angles will be equal by theorem, is it not? Angle PTR, angle of the circumference, will be equal to angle PSR. Why it is so? It is by theorem. What is given now here? That is given to be 35 degrees. And therefore, so it is 1 mark question. Angle PSR is also equal to 35 degrees. That is by theorem. What the theorem says? Angle at the circumferences will be equal. And what about this angle? This will be double that angle, okay? So very simple question, provided you know the theorem. That these two angles formed at the circumferences will be equal, okay? Noted? We will pass on to next question, okay? Next question is, in adjacent figure, O is the center of the circle and AOB is 60 degrees. Find ADB. You know AB is the arc. So solution is see, arc AB forms two angles. One is angle at the center AOB. Arc AB forms angle AOB 60 degrees at the center. And what is ADB? ADB is the angle formed at the circumference, right? So therefore, a relation between the two, angle AOB is equal to 2 times angle ADB. That is by theorem. What does the theorem says? The theorem says angle at the center, double the angle at the circumference. Or in other words, suppose you want to find out angle at the circumference, then ADB will be equal to half of angle AOB. That is half of, what is AOB given? 60 degrees. That is equal to 30 degrees. So ADB becomes 30 degrees because both of them are formed by the same arc, AB. Alright. So this is a very, very short and sweet question. Just 1 mark. Okay. I hope all of you have noted down. Shall we pass on to today's topic? We will pass on some more problems on this. Here is a figure. O is the center of the circle. Angle AOC 120. They are asking find ABC. So, what is the solution for that? So, first you must know the theorem here. See, this is the angle formed at the center. If this is 120, what about the remaining angle? 360 minus 120 will be 240. And this is angle at the circumference, the remaining part. So that will be equal to half of that. That also will be equal to 120. Is it not? That's all the answer. ABC becomes 120. Okay. Now you must write first angle AOC is given to be 120 degrees. That is given. It is formed by which arc? It is formed by the arc ABC. Is it not? Therefore, remaining angle AOC, if this is 120, will be equal to 360 minus 120. That is equal to 240. Is it not? So, this angle 240 is formed by this arc APC. And what is the angle at the circumference formed by APC in the remaining part? This is ABC. Is it not? So, angle ABC, that is the angular circumference formed by the arc APC in the remaining part. This is the part we have taken, 240, half of 240, that is 120. That is by theorem. And what does the theorem says? The theorem says angle at the center is double the angle at the circumference, or angular circumference is half of this center angle. How do you get 240? Total is 360. In that you subtract 120. You got 240. So half of that is 120. Right? That's all the question. Is it alright? Taken down? Very happy. We'll go to next question. One more question, same type. In the given figure, O is the central circle. POQ is 70. So POQ is the angle formed by the arc PQ. And PS is perpendicular to OQ. So perpendicular means what? This angle becomes 90 degrees. They are asking what is the angle MQS. Okay. So we will solve this problem. It has got one more step extra. So POQ is 170 now. We are given that POQ is equal to 70 degrees. And what is the angle formed by the same arc at the circumference? That is PSQ. Therefore, angle PSQ is equal to half of 70. That is 35. That is by theorem. What the theorem says? Angle at the center is double the angular circumference. So this becomes 35. Now you are given one more thing. We are given that PS is perpendicular to OQ. They are perpendicular. Means what? Angle SMQ. Therefore, angle SMQ, or you can say, yes, SMQ. SMQ will be equal to 90 degrees. That is understood. Now, in triangle, they are asking MQS. Last point. In triangle MQS. See here. MQS, angle M is 90 degrees given. This is 90 given. This is 35. So angle MQS becomes 180. Writing down? No. Come on. Start writing. This I understood, no? Simple. This also understood. Last point. What is sum of the three angles of a triangle? 180. So 180 minus, what is given? 90 is given. What you just now found out? 35. So that will be equal to 180 minus 125. How much? 10 minus 5 is 5. Then 7 minus 2 is 5, 55 degrees. So this is 55, that is 35, this is 90. Okay? It's a 2-mark question. And how do you got this? This is half of this. If this is 70, this becomes 35. And this is given as 90. So 90 plus 35 plus that 55. That becomes a complete triangle. Okay? Alright? Noted? Okay, very happy. We will pass on to what is meant by concyclic points. So what are concyclic points? The points which lie on the same circle are called concyclic points. What do you mean non-collinear points? Non-collinear means which are not in the same straight line. See, there are, if the points like this, A, B, C, D, different points, not on the same line, we call it as non-collinear points. And so this, at a given point, you can do any number of circles. Of course, you can also try to draw it in compass, beautiful designs. How many of you draw this Rangoli? Yes, girls will know very well. There you can draw this type of circles. Nowadays, ready-made circles also come, right? So here, there is a point called P. So passing through a point, you can draw any number of circles. There will be like tangents here. See, all of them pass through this. Is it not? And they are all called, the point P is the same point for all type of circles. Now coming to non-collinear points, here what do you get? If the non-collinear points is 1, so here P, Q, R, this is called concyclic point. And in the concyclic point, you have only one circle. See, just see this. It is concyclic point. Concyclic means lying on the same circle. And if you take the points like P, Q, R, S, which do not lie on the same line, you will see that it is not always possible to draw a circle passing through the 4 non-collinear points. So, for example, here, this is called, what we call as concyclic points. Figure C. Here, this is non-collinear points. And it is non-concyclic also because the S point is away. It may be like this also. So, A and B are called non-cyclic. Why it is non-cyclic? S is outside. But this is called concyclic because S is inside. Following? So, everything, the word cyclic comes there. Cyclic means what? Lying on the same circle. Here are the points which lie outside the circle. Therefore, they are called non-cyclic. And that is called concyclic. And all of you know one word called cycle, is it? How many know cycle? Almost all. Everybody. Super. Who discovered cycle? What, sir? Geometry you are asking. Who discovered? Should know, no. Anybody? Yes, it is Macmillan. Note down. Bicycle was discovered by Macmillan. How many circles will be there? There will be 2 tires, right? It acts like circle. It's not exactly circles. Almost similar to circle. You can take that. Okay. And there will be one, there will be what is called as spokes in the cycle. And the spokes acts as radius, right? All these spokes will be equal in length. Therefore, we say radii are equal. And there will be what is called as washer. And there you fill up the air is in. So that is called concyclic point. So here also, this is called, the points are called concyclic points. And this point is away from the circle. And that is called non-cyclic points. Okay. So this is one new word you must add to your dictionary. And so we can conclude that given 1 or 2 points, there are infinitely many circles passing through them. Other time you are shown that you're passing through one point, any number of circles can be drawn because the radius difference, the change in the radius. So 3 non-collinear points are always concyclic, and there is only one circle passing through them, all of them. So take say 3 points A, B, C. Somewhere you can draw, nothing like that. They are called non-collinear. What do you mean non-collinear? They are not lying on the same line. Collinear means what? See, this is called collinear points, which lie on the same line. A, B, C is called collinear points because they pass through the same line. This is called non-collinear points because they do not lie on the same line. How many circles you can draw here? You can have, so you must draw what is called as perpendicular bisectors. And you will have a center here and a circle should pass through them. I am drawing a rough figure and only one circle can be drawn to pass through this. Suppose you have points like this, so you call it as A, B and C. They are non-collinear points. And if you draw, how to find the center? Draw the perpendicular bisectors. You already studied this in 8th class. So they pass through a center, and this is called non-collinear points, and they are called concyclic points because they pass through the same circle, and only one circle is passing through these points. Followed? Because you will have only one center, only one radius, right? One more thing. 3 collinear points are not concyclic. So collinear points means what? Suppose you have points like P, Q, R. They pass through the same center. They are called collinear points. They are not concyclic because you cannot make all the 3 points pass through the same circle. Is it not? So that is another interesting result here. You should note. And lastly, 4 non-collinear points may or may not be concyclic. 4 means what? So suppose you have points like P, Q, R, S. I have shown it already once. Suppose you have these 4 points P, Q, R. They are called non-collinear points. A circle may pass through them, all of them, or some of them, 1 or 2 like that. So that is the meaning. We have already seen the figure. So these are the results of this. Okay. Now let us see what a home assignment. A square PQRS is inscribed in a circle with center O. What angle does each side subtend at the center? Can you do it? Super. Try to do it. Here are 2 circles. These are 2 circles and they intersect each other at A and B. AC and AD are the diameters. AC is one diameter, AD is another diameter of the circle. Prove that CBD is collinear. CBD. Collinear means what? They pass to the same point. So these are the 2 homeworks. Come prepared. Let us see what Sadhguru Madhusudan Sai say. With that we will close. See the beautiful photo of Swami. More than good marks, it is important that you get good remarks. Swami says, more than marks, remarks is important. Means you should get good remark. Okay. So this is Sadhguru Madhusudan Sai, which all of you know that he is the incarnation of Bhagavan Sathya Sai Baba. He says, try to get good remarks. So that is very important. Okay. So come prepared with the answers. Thank you.